All right. Well, thank you all for coming to this talk, Curious Perversions in Information Technology. Before I get started, let me give a little bit of background about myself. My name is Alex Papadimoulis, and I'm a programmer. I've been a software developer now for a little bit more than a decade. And, I've worked at a whole lot of different places, from, small one-man shops, just me obviously, to, the large soul-sucking corporation. These days I work for my own small consulting company and have a lot of fun doing that. Another thing that I do is I'm the editor of the website thedailywtf.com. Now, if you haven't been to the Daily WTF, its tagline is Curious Perversions in Information Technology. The same tagline, or the same title as this presentation. So if you go there, you can see all sorts of, fun perversions in IT. So, a little bit about the site here. It started several years back when I worked at a relatively small consulting company. A large part of my job was maintaining other people's code. And I don't know how many of you guys are developers, but, I was just astonished at a lot of the really, really bad code that I had to maintain. We're talking some really bad stuff here. Hundreds of lines of code to parse an integer. This, I should note, is in high-level languages like BASIC or, C#. Thousands of lines of code to parse, date, time. You don't even want to see the code that they had to do to, turn an integer into hexadecimal. It was crazy. So, just one day, I had enough. I just couldn't take it anymore and did like any other developer in my position did and blogged about it. So this, for whatever reason, on this day, this is what really bugged me. I don't know if you know how many of you know databases too well, but what this is this is a database table. It was a critical production table that had no rows in it. All it had was a bunch of columns that had the same name as their data type. For whatever reason, it was critical, and it, just really bugged me that day. So I complained about it and posted it. What I found was that it felt good to complain. I really liked bitching about work. And the next day, I had something else to complain. So I posted that. The third day, I posted something else. Next thing I know, people were sending me really bad code to post as well. So I started posting that, registered the Daily WTF, and there we go. So that's, it turns out that I was not alone with bad code. Now I'm curious about you guys. So I was hoping to get a show of hands for how many programmers, developers, code monkeys we have. Cool. Now, how many of you guys work with programmers, developers, code monkeys? So that's just about everyone. I don't think, we're going to need a show of hands for this one, but who has used software that sucks? All of us. The question is why, but before we get into that, let's take a look at some bad software. These are some screenshots from a feature I run on the Daily WTF. Users send in all sorts of weird error messages that they get from software. Here's one that somebody came across on Netflix. If you enjoyed Last of the Mohicans, I think you'll enjoy Last of the Mohicans. This is from a bug tracking application internally. It was for, when users complained about their Aramaic version not working. I'm going to say no. Those who have children might find this a little disturbing, Retry. That's got to be it. And then we've got one of my favorites here, 872-349-2872438. Shit, that's not prime. So, the question is, how do we get messages like this? How the heck do we get software to just spew out these ridiculous error messages? Sometimes, it's just the right combination of things that are happening. Who knows? There's just that many users on the server. There's just, the right edge case in the algorithm that's not being considered. Usually, though, it's going to be bad code that's behind it. So just to give you an idea, here's a bit of like pseudo C# code here that kind of, is some bad code. What we have here is the developer is doing all sorts of things, with an order, order ID, adding items to the list. And regardless of what happens anywhere along the way, all we have at the end is, oops, something bad happened. That's worse than useless, because how could anybody debug that if a user were to get that? There's no idea of how to fix it, and that's why we see a lot of these error messages that just don't make sense, like that oops, child died. Pretty useless. So the next question then is, how the heck do we end up with bad code like this? Obvious. It's the bad developers. Now, those of you who are software developers or work software developers probably know exactly who I'm talking about. A lot of times these developers have code named after them. The Dave code, the Jed code, the Brian code. And oftentimes that code lives long after they're gone and out wreaking havoc somewhere else. And you always hear the other developers just cursing, damn Jed, damn Dave, and that's just where a lot of these, where a lot of the code comes from. I've worked with a lot of bad developers in my day, but one of the worst, actually I'm going to say the worst, is, if I can get this, Marcus. Marcus didn't care at all about software. It was his job. He was a programmer, but it just wasn't his thing. He was in at 9:05, 9:10 every day. He left 4:55 every day, and it's just he was a really lazy guy. And actually, funny thing, the one time I did see him in the office after 5, it was like 6:30 or something like that, and I said, Marcus, what the heck are you still doing here? Do you have a deadline or something? That, never worked for Marcus, because Marcus never met deadlines. As long as, if he couldn't get it done by 5, it wasn't getting done. Well, it turns out Marcus was in the room, was still there because he was just hanging out to go to WrestleMania later that night. And that was, that was his thing. There's absolutely nothing wrong with professional wrestling. Who doesn't love the drama between The Undertaker and the Irish guy? It's a lot of fun, But the thing is that's all that Marcus cared about. When he was in the office, he wasn't thinking, gosh, how the hell do I solve this problem with code? He's thinking, gosh, I wonder who's going to win in tonight's, whatever the heck they call the events. And by the way, I should note, that's why I feel very safe talking about Marcus here, because this is the last place he would ever come. He's not the type to do anything, outside the office. So one thing that I remember about Marcus, and one of the few pieces of code that I saved that he wrote, was code that compared two strings. Now this is, this was in .NET, C#, and I, don't know how many of you guys are C# developers, but comparing two strings in C# is very, very easy. You have string A here, your second string there, equal. The result of that expression is true if the strings compare, false if they don't. So how did Marcus do it? Like that. Now, the first time I saw this, when you see stuff like this, it's, I was speechless. But let me do a quick walkthrough of what this code is all about. First, he compares that the two strings are null, if either one of them is null. But he really liked this strange ternary operator. So you can see if they're null, then 1, but if 1 is equal to 0, then they're not equal. It was just his way of doing things. It's really a roundabout way to, check for equal. So the next thing he did is he converted both. He checked the length of both strings. Obviously, if they're not equal, the strings aren't equal. Then he converted them to a character array. And again, checked the length just because, who knows, maybe the first time was lying. Then again, he loops over each character, checking for the null terminator, which doesn't really make sense in C# or .NET, because that's not how we really end strings. But, that's what he did. I think that he got it from, what I believe happened is how he ended up at code like this is he Googled, how do you compare two strings? Came across this. I mean, this looks kind of sort of like a bastardization of the strcmp function in C, and it kind of ended up here. So that's how he ended. That's how he ended up with this. So this was just a representative example of the code that he wrote. It was all like this. It was all really, really amazingly bad. I mean, I couldn't even think of writing code like that. I don't know how anybody does. But when I went to him and I said, Marcus, why did you write this code? Why? His response, it works the same. Well, it doesn't in all cases, but for what we needed to do, it worked the same. And what he said further is, sure, it works the same. And yeah, I might have wasted 20, 30, 40, 2 hours writing that function, but now I can reuse it. And that he did. So that R equal function was in every single project he wrote. And as were all the other functions that he put in functions.cs. So that was pretty painful. Now, Marcus and folks like Marcus are, in the world of professional programmers, are really the bottom of the barrel. They're the opposite of the, creme de la creme, which is where this really bad pun came in. They're everywhere, except for here. Again, because, and I'm not just saying that, I mean, really, the people who are in that bottom 5% aren't going to be going and taking their weekends, especially this early on a Saturday, to come in and learn about technology. These bottom of the industry guys are in every single industry, from hair care, finance. There is even the worst pilot. Somebody has to be the worst, and he's probably out there flying a plane, hopefully not one that any of you are going to fly back on or anything. What astonishes me is how these guys manage to get jobs, and it's actually pretty simple. If you think about it, think of yourself, and this is a little hard to do for a lot of reasons, but put yourself in Marcus's shoes. How the hell did he get a programmer job? Well, it's simple. Try, repeat 100 times, try again. Eventually, he's going to get it. Somebody's going to, hire him. He's going to learn all the tricks, and, for a few years, he'll be in his job, and it'll be, a long time before anyone else can, can figure out. Now, no matter where you work, even if you run your own company, you have to learn to deal with bad programmers, just bad people in the industry, because how many of us get to choose our own workers and clients? Well, I'm sure, Drew, he doesn't have any clients to worry about, so you're lucky in that aspect. Yeah. But yeah, I mean, I have my own company, and I have to work, I have to deal with clients who are very similar to the Marcuses. So what I came up with over the years in working with bad developers is some tips and tricks to deal with some of these guys. Bad developer damage control. The first way to really kind of deal with the bad developers is overhead. You would be surprised how many bad developers hate source control, issue tracking. And when you make them use it, it gives them a chance to use it as an excuse to write less code. Less code is better for everyone. You'd be surprised that when you just go in Excel, generate columns and columns of random data, print it out, and then go, Marcus, I'm going to need you to program this in a language called Excel. It's pretty simple, just type numbers in here, and there, and there, and there. That's going to keep him busy for weeks. Not very useful, but you know, it's a good way to get him to pass time. Remember, these guys don't like staying in the office anywhere past the core hours. So schedule code review early in the morning, late at night. They're going to, obviously they're going to have to write code. It's going to have to go in production, but if you schedule code reviews early on, they're going to, again, want to write less code, which is a good thing. And then the last tip is management. I don't mean that so much in, try to get them to be your boss, but give them useless management things to do. Task management. One title that I've always found works well is anything that has the word liaison in it. The one place that I worked with, he was a developer. His title was, senior developer. Senior because he was there for like 10 years. He was the requirements liaison and did nothing but just talk to business analysts. Perfectly useless, but it got him writing less code, and that was good for us all. So the bad news, though, is as bad as the Marcuses of the world are, they are not the worst problem with software. They are not the real reason that software sucks. I mean, think about it. There aren't that many at the bottom of the barrel. And those that are, they don't write that much code. The scope of their, damage is really limited to the things that they've touched. And honestly, it's really easy to undo a lot of their damage. The real reason that software sucks is kind of the opposite. It's the really good developers, the guys who are really, really smart. That seems a little counterintuitive, but, there was one guy that I worked with who, well, before I get into that, though, there's a really good reason why brilliant developers, cause a lot of problems. The first reason is software is really, really boring. Most software, I should say. Most software is the type of software that you use to power mortgage loan application processing or, do stuff like commission tracking, time logging. This isn't very exciting stuff. This isn't like the PageRank algorithm or some of the stuff that, hardware programming. That sounds fun. That sounds challenging. But for the most part, software is really, really boring. And by their very nature, developers are pretty smart, I mean, I don't know how many went through a, computer science curriculum, but some of the classes that you have to go through in that, compiler design, calculus, linear algebra, this is not easy stuff, and not anybody can do it. I mean, even Marcus, who, again, bottom of the barrel, is probably a bit smarter than the average guy who hasn't gone through, have that background. So if you take these two facts, number one, software is boring, developers are smart, it combines into a bad thing. When you give a menial task, writing boring software, to highly capable individuals, it doesn't end up going well a lot of times. I'm going to bring out a quote from Michael Jackson. Not that Michael Jackson. Michael Jackson is still a writer, teacher. He's been doing software for longer than most of us have been alive. And his quote is, Programmers often take a refuge in an understandable but disastrous inclination towards complexity and ingenuity in their work. Forbidden to design anything larger than a program, which in 1975, there were programs, modules, things on top of that. So what he means here, given a relatively small task, they will respond by making that program intricate enough to challenge their professional skill. They make things overcomplicated. So, what's interesting is that he observed this in 1975, and in my experience, this exact problem, the really brilliant programmers, the guys who are overcomplicating things, are the biggest reason for all of the major software disasters out there that we've seen. One that I had the fortune of being a large part in was with a fellow several years back named Brandon. Brandon was an incredibly smart guy. I'm not kidding. He had, several degrees from pretty good universities. He wrote, I want to say, 7 books. He had every certification I've ever heard of. And, not only that, he worked in every single industry out there. Healthcare, finance, manufacturing. And that was really, he was a really, really smart guy. So you'd think that he'd be a great guy to work with on the team. Well, what had happened is the project that we worked on, it was a pretty big and boring project. It was used by a larger company to really run an entire floor of people. And it was a really highly regulated industry, and to really even read the requirements, you practically had to have a law degree. The system did nothing but, push paper, scan paper, in and out, incredibly, incredibly boring, boring stuff. So how we divided up the team, well, not we, how they did, was Brandon, he was the team lead for several database developers, and my team, which was the front end, we kind of worked together with them to build this wonderful system for, the hundreds of users in there. Now, the system was designed to, this was a Microsoft shop. All of their infrastructure was Microsoft technology. So the logical choice at the time for the front end was ASP.NET. That's what all the front-end developers were good with, and that's what we had the infrastructure for. The back end, obviously, SQL Server. What else do you have in a Microsoft shop? They had the infrastructure again for that, so that's what we chose to run this. So then, what did they choose for the middle tier? dBase. Seriously. Now, if you don't know what dBase is, it's it's a older kind of technology. Oh, not really that older. It was from the 90s, and it was a new concept of development for kind of rapid application development. It stored all of its database tables as files. It had its own programming language. It was really integrated. Some related products are dBase, obviously dBase. Clipper is a related product. FoxPro. I would say it's a lot more complicated version of Microsoft Access, whereas Microsoft Access is, for end users to build applications really fast. dBase is for developers to build, applications really fast. This makes absolutely no sense. ASP.NET is built to communicate with SQL. So, I objected, as did everybody else, but not Brandon, Brandon had a lot of reasons for why dBase was the perfect, was the perfect solution for the middle tier. It was incredibly fast. That's what he said, at least. In fact, these are just mostly his arguments, and to this day they make no sense to me. It had unparalleled string manipulation. What else? It could process raw SQL Server data very well, which again doesn't make much sense since ASP.NET can do that very well. Probably, though, the big reason for it was Brandon was one of the world's foremost experts on dBase. 4 of the books he had written was on dBase. And, if you think about it, the .NET guy versus Mr. 2 university degrees, several books written on him, he won out. But actually, there was a real reason that he wanted to use dBase. It was for a product that he had been working on for years and years and years that he called XP dBase. XP, I think, stood for expandable, but none of us ever really knew. What it was actually a framework built on top of, on top of dBase. And his big argument for this was he had been doing this for 10 years. He had built this framework up over 10 years, and it has a proven track record. And obviously, he built it. He has a lot of good credentials, so it was the way to go. The main selling point for dBase really was its simplicity. This application with all the complex requirements, obviously the front-end developers couldn't possibly grasp that. So, the XP dBase framework was there to simplify our life. It would turn complex applications into, really, really simple tasks. The way that it did this was with something that he called entities. And what an entity was it really was just a dBase function that had, a dBase class that had 2 functions, get and save. And all entities were dynamically coded. Dynamically compiled, and we'll cover that in a second here, with, of course, the exception of the entity, which managed all of the other entities. This is already starting to sound like a fun system, I can tell. The other main thing that XP dBase did is it could connect to any type of data source imaginable, in theory, of course. Oracle, MySQL, SQL Server, another dBase product. We only needed SQL Server, but it was there, and that was important to Brandon. It was also really, really good with security. You see, one of the things is every time you called one of those 2 methods on an entity, you had to pass in a user ID. So it had this very complicated permissions security mapping system to make sure that the user ID was allowed to call that entity. It was all very elegant, as Brandon said. So as I mentioned before, there are really 2 methods on the XP dBase entity, or entities. The first we have is called the get, right? And how, what a get would do is if you call, the XPDB framework, the first thing that you pass in is the entity name. There were, I think, maybe 150 or so different entities, all with as useful names as Lone App. Then you have a filter string, and the thing about filter strings is that it was really important that you had the spacing perfect if you wanted to filter by, let's say, application status, and the person who filled out the application, they had to be in the exact order. Otherwise, the system would respond with really, really odd output. And everything that the XP dBase did is it returned XML. The XML was just it was generic XML of a data set, or of a series of rows in a table. So we converted the XML into what you would pretty much get if you called a select statement from a database. Then, of course, we have the save. And as you can tell from this, the save was not pretty at all. It in theory worked the same way. Okay, so you have the Lone App as the first parameter, the user ID as the second parameter, but then you had the concept of the save string. I'm sure, if any of you have ever written an update statement, this is so much simpler. The first thing you pass in, it is a asterisk tilde delimited string that ends with pseudo somewhat kind of HTML. In this case, Lone App, that's the underlying SQL Server table. So you would pass in your parameters or rows kind of as, asterisk tilde attribute value pairs. One of the big things that he said was so great about his system was that you could, by putting many records in it, you could do multiple updates with one single statement. Now, it didn't work on all entities, and when it did work, it crashed a lot. So we never actually did it, but in theory, you could do it. But what's cool is that's not all that XP dBase was all about. The main thing about it is dynamicness. If you think about it, compiling software is a huge pain in the ass. You have to go to the build menu and then click compile, wait 4 seconds, and then take your DLL and use it. Well, Brandon's XP dBase, everything was dynamic. And use dynamic classes in dBase. So how did he do that? Well, it's actually pretty simple. A step-by-step kind of process here is all of these entity classes were in a table called entities. And what this table was, it had entity name and then a memo column that had all of the class code in it. So that's how these entities or classes were coded. He would take the code out of that database table, save it as a temp file on disk, and then compile the class into memory, and from there call the get or save method that we originally requested. And of course, on top of all that, there was the security, the connection management that the XP dBase framework all handled. But what's even cooler is that not only was XP dBase dynamic, it was doubly dynamic. Not only were the entities dynamic themselves, but the dynamic entities could be even more dynamic, and there's a good reason for this. If you think about it, okay, when you write code that's database code or interacts with the database, what are you doing? You're selecting from a table, returning a result set, updating, inserting. It's all very much the same code that pretty much is pretty generic. So Brandon's solution was this. Instead of using a select query on most of his entities, these all represent dBase tables. There's 7 of them total. This is just I summed it up, but it got a lot more complex to build a select statement. For a select statement, you had selection tables. So if you wanted to select 7 columns, 7 rows went into the selection table. Where your from would normally go, you put that in the source table. And it all it turned a database query, a simple select query, into a whole relational thing. He even managed to do it for updates and insert statements, which I was never actually able to understand. But I did have a diagram of it, and I didn't really, maybe now that we have a screen this big, it would have fit. But on my laptop, there were, I think, at least 50 tables that he had to use to build those. So I didn't show those. So with all this really easy to develop stuff, how do you think all of it turned out in the end after nearly a year of I think, 12 full-time developers working on it, and building this system? Well, not so good on launch day, as it turned out. Actually, within hours of the system, starting up, and turning on to give out to the users, the entire system ground to a complete halt. Nobody could access anything. Every single page locked up. It turned out that it was a bug in Brandon's dynamic inserts. For whatever reason, he was opening transactions but never closing them. It took him a while to debug that and figure that out, but in the meantime, which was for 2 really intense days, it was actually a DBA's full-time job to go into SQL Server, refresh on the open processes screen, look at the ones that had been open for more than a few seconds, and right-click and kill them. That's all he did all day, was just click in the database, kill process. But it worked, but obviously that meant 2 users out of 300 or so could use it. But after a few days, they were finally able to get it back up and running. So after the first week, they realized that this system that everyone had built was incredibly, incredibly slow. We're talking, almost a minute for a page to load. Just a page that listed some data out of the database, which would take microseconds, had we just gone to the database directly, of course. So what Brandon said was, obviously, our Quad Xeon computers, or whatever the heck we had, they were about $10,000 a piece for the database and web server. They weren't powerful enough to power that many users. So they bought 4 more servers to bring it up to a total of 6. 3 for the database, 3 for the front end. And actually that made things a little bit better. Page times went from 30 seconds to 3 seconds. So it was an improvement. Now, the problem was, though, about a couple months later, the system started just progressively getting slower. One of the things Brandon didn't really believe in either was database indexes. And, when you have a lot of data in there, and he also didn't really like where clauses a lot, so he was pulling entire table sets, filtering them in dBase. So what that ended up happening is we went back to, it actually got worse than what the week 1 was. There was, and what did Brandon say at this point? Well, nothing, because he, went on to do bigger and better things, scarily enough, after calling this a success. So there was really absolutely nothing we could do other than try to just patch it with duct tape over the next few months. And in the end, after 9 months, well over $1 million of development cost, they scrapped the whole system because it was totally, totally unusable. So the thing is this is not an uncommon story. If you've ever heard of these giant disasters in IT, like the FBI's virtual case file. I don't know if that's too familiar, but that was $70 million train wreck of a problem. All because, and of course the reports and postmortems don't give the technical details, but a lot of times it ends up happening just like this. After a few months of use, the system is totally, totally unusable. The question then is, with Brandon being such a smart guy, how the heck did such a horrible, horrible system get built? Obviously, XP-dBase had been in his mind for years and years and years. Every project before this big one, he had been, using some bastardization of XP-dBase, some smaller version of it to power it. And, as the projects went on, as he evolved this solution, he would figure out more, he would identify more problems, and then to fix those problems, he'd add even more problems on until he just ended up with XP-dBase. This project was one of the biggest that he had worked on with XP-dBase, and it provided him and his 6 developers the opportunity to put all of the, his brilliant idea into play. Practicality be damned was really his way of thinking. He tricked himself into thinking that all of the development hours that he focused and all of the time that everyone put was really for the better good of the system. And all along the ways, he'd throw aside requirements and say, no, we got to focus on this feature of XP-dBase. And he was really on the quest to create the perfect dynamic solution that nobody would ever have to write code for, but somehow would solve all of the, requirements. The real problem was that he was always, looking the wrong way. He never saw this as a chance to build this really boring information system that did nothing but push paper between several hundred different people. He saw it as the perfect, solution to the perfect opportunity to build this really complex beast. In the end, Brandon was too clever for his own good. I hate to use the pun there, but this is a perfect example of that. So, one of the takeaways from this is, this can happen to all of us. Any one of us can be caught up in our own cleverness. Looking back at some of the things that I did, it's actually really embarrassing just thinking of how I thought this could have been a good idea to do. Obviously, I didn't build anything like dBase, but maybe if I had enough delusion and worked at it long enough, maybe I would have built it. I don't know. But like dealing with bad developers, this is something that we really need to be careful of. When we're building systems. Avoiding being too clever is almost as can be certainly pretty easy. The first tip that I have to kind of help avoid this is the G.I. Joe rule. Knowing is half the battle. Really, now that everyone here has learned about dBase, I don't think any of you guys are ever going to build it for your clients or for anything like that. It's just not gonna it's not gonna happen. The second one is, of course, the buddy system. After you build your initial specs, after you think it all out, show it to a friend. Show it to your coworkers, show it to your colleagues. Chances are they're not as insane as you, and they aren't caught up in the requirements as much, and they can give you a clean perspective. Just last year, I really, no joking, made a UI abstraction layer in the event that this product that we were building might have a web and a Windows interface. And at the time, it seemed like the greatest idea, because this way we can code the UI and not have to worry about how Windows and the web acts. And as soon as I showed it to somebody, he had really 3 words to say that can be summed up with WTF. The problem with the buddy system, though, is that it can kind of get into what's called groupthink. The demotivational poster, I think, sums up groupthink the best. None of us is as dumb as all of us. Obviously Brandon wasn't the only one who thought dBase was a great idea. His entire team did. 6 relatively, intelligent people, led by a really, really smart guy, all believed that what they were building was a great system. And, similarly, it's easy to get your team caught up in, really, really bad things as well. So that's something to be careful about. Probably the best way, and this is certainly something that I'm sure just about everyone here has learned as well, is put your cleverness in a hobby. Take demos, for example. That is some of the most clever things I have ever seen. I have no idea how these incredible things can be compacted into 4K of code. That to me takes some incredibly clever things. That cleverness belongs in fun stuff, like demos, like hacking. It's not something that you want to deliver to a client who just wants to have a system that they can enter data in, get it out, and print it out. We don't need that really complex stuff for that. And the final kind of tip that I'm gonna leave with is something that it's just one simple word called gloves. Now, gloves probably doesn't make any sense unless you've heard the accompanying story. Now, and this is something that one of the readers of WTF sent in a while back. He worked at a large consulting company that did, they were one of the big ones. There were thousands of developers through it, and they were consequently one of the consulting companies that is quite often behind the 10, $100 million disasters. And one day, some folks out of their New England office posted on their off-topic internal discussion board that on his bike ride to work, he noticed that the brisk morning kept his hands pretty damn cold. And he looked online and was very surprised that no one had invented a hand warming system for the bike. So he could put his hands on the handlebars and it would warm it, kind of like a heated steering wheel for a car, perhaps. So when he first posted that, that started a whole torrent of discussion. Somebody immediately replied, well, gee, you know what we could do? We could attach a dynamo to the to the wheel and then use that to generate heat for your hands. That would work. Then they went about and how, well, that might cause too much. You'll lose torque, you'll lose power. So, several hours and I'm sure hundreds of hours of build client time later, they came up with the ultimate solution, which I wish I had a diagram of it, but it involved a thin outer jacket that had several veins of water through it, inlet and outlet valves, a battery backup powered dynamo that used compression valves to reuse body heat, and if it didn't get hot enough, if you weren't warm enough, then it would use the dynamo to run over the handlebars and also something over your hands. And at the end, and I think this was sometime after lunch, after all these, huge discussion, somebody just posted and said that there's a really good reason that this system hasn't been invented. Because there's already a pretty suitable way to warm your hands. It's called gloves. That pretty much ended the discussion there. Nobody really thought, wow, we can use gloves. So, leaving on that, I'll say, take a good, hard look at your first submission and just say to yourself, gloves. So that's really all I had for the presentation. I'm not sure how we're doing on time, but any sort of questions or comments? How are we on time? Does anybody?
We got like 3 or 4 minutes, maybe.
Okay. Well, that's it that I had. And if there's no other question, if there's no questions or anything, I guess that's it. So, thank you. Thanks.
I'm your successor here.
Oh, cool. Cool. Awesome.
Stick around to hear about it from Senate. One was already there. Oh, you gotta be kidding me. Please, please, please work.